Hello, STEM Nation. Jeff here, and welcome to episode number 84 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math to help guide students interested in STEM careers. If you like what you hear, please share it with a friend. Now let's get fired up today with our guest Stephanie, and I hope our chat will help ignite your passion towards a STEM career. Stephanie has a PhD in physics and is focused on solar physics and is currently doing post-doctoral research at the University of St. Andrews in Scotland. Welcome to the show, Stephanie. Fill any gaps and share a bit of your personal life.
Well, thank you for having me on the show, Jeff. I'm a post-doctoral research fellow at the University of St. Andrews in Scotland, and my research is focused on studying these huge eruptions that come from the sun. They can hit us here at Earth and cause huge disruptions to our technological systems.
So, Stephanie, you're studying solar flares, and I'm an electrical engineer, and I understand that when you get solar flares, there's solar energy that gets created, magnetic fields, alpha particles. I'm not sure I quite understand exactly what gets created, but it does affect electronics. So, can you go into a little bit about how you predict this and what type of impact it has on electronics today?
Yeah, so there are different types of solar phenomena. You've got the solar wind, which is essentially the extension of the sun, which is constantly hitting the Earth. That's one of the things that can cause the aurora and these technological problems. You have solar flares, which are these intense patches of brightness on the sun, and these accelerate energetic particles at us. And then we have these huge eruptions that come from the sun that travel at hundreds or thousands of kilometers per second. And they also hit us, slam into the Earth and cause these technological disruptions. And the main problems we face are we have problems with any satellites up there. So anything to do with GPS signals, radio signals. We get radio blackouts if there's a huge storm, and the aurora, you can see the aurora, that gets quite disturbed, the auroral oval. You also get problems with the power systems, so that's a real big problem for people. For in the UK, we have what is known as the national grid, and so they have to protect the transformers and the coils in the transformers. So it affects everyone on a daily basis, really, whether you're just a civilian or whether you actually need these satellites for whether it's communications or anything else, really.
So, Stephanie, how did you get into this field?
So when I was little, I always used to take things apart and fix things. So I'm surprised really that maybe I would have been an engineer instead, but I really liked maths at school. I guess a lot of people might not actually admit to that, but I really enjoyed maths, and I really enjoyed applied maths. So physics was on the cards, but there was two things really. There was a trip that I got to go on when I was about 16 or 17, and that was to Johnson and Kennedy Space Centres, and it was an all expenses paid trip It was through the Gifted and Talented initiative that we have here. And I couldn't believe my luck. I got to meet 5 or 6 astronauts, talk to them. I got to go in the vehicle assembly building. I got to go around the 2 space centres. And that was kind of what made me choose physics and go on to do physics at university. And I was just really interested in astrophysics. But then I got talking to one of the professors at the university I was studying at, and they said, well, have you thought about the sun? The sun's particularly interesting. And so I've gone from thinking about studying a PhD in really exotic objects like black holes and binary systems and white dwarfs to actually our sun is quite interesting, and it's our closest star. It affects us on a daily basis. So I ended up doing a small research project, like an internship during my 3rd and 4th year at university, and then I got hooked on the sun, and ever since then all my projects have either been, whether it's at university and doing my masters, my projects were about the sun, and then I went on to do my PhD in solar physics. So it kind of stemmed from there. It wasn't what I initially thought I'd specialise in, but sometimes you kind of fall into these things, and that's kind of how it happened.
Yeah, absolutely, Stephanie. I mean, you have to have an open mind as opportunities come your way, which it sounds like you did. As different opportunities flowed your way, you took advantage of those. So if we look forward, you're doing post-doctoral research, which means research after your PhD. What comes in the future? If you could look out 5-10 years, are you still doing research at the university?
So I'm hoping to stay in academia and stay in research. It's sometimes can be quite difficult to do so because of the funding. I'm lucky enough to have just had my contract extended for another 3 years, so I'll be a postdoc for the next 3 years at the University of St Andrews. But I'm hoping eventually that I will either get a fellowship or secure a fellowship and then eventually a permanent position. So working towards getting a lectureship and then continue from there. I know the UK and the US system is slightly different on this, but essentially I'm looking for that permanent position at university.
So Stephanie, thinking of our STEM Nation audience, which are juniors, seniors in high school and early college students, and they're thinking about this. Okay, you know what? I really like the solar system and studying black holes or studying the sun, but I don't really want to be a researcher, right? I don't want to be in academia. What are some of the paths that they could follow outside of academia? Well,
it depends what you're interested in, because I think I knew that physics, it wasn't why I chose physics, but I knew physics was quite a broad subject. So you could do anything really. You could teach, so you could become a physics teacher and teach about astrophysics, stuff like that. I'm obviously a research scientist, but you can go into the engineering side. So there's a lot of my friends that build parts that go onto the go on the satellites, or build instruments that go on the satellites. But then there's other things. So there's forecasting. So whether you like kind of weather forecasting or space weather forecasting, from these, looking at these eruptions and trying to predict them. There's loads of things. You could be a geologist, a meteorologist. You could go into the energy sector. That's quite a big sector at the moment, or anything to do with technology. So I think that it really does open doors for you if you do that kind of degree.
All right. Thanks for that insight, Stephanie. I'm going to ask you a question here. What's one thing that you think would be really interesting for the audience to know that we don't know about the sun?
Oh, that's an interesting one. So one of my favourite facts about the sun is, so the light roughly from the sun's surface takes about 8.5 minutes to reach us. So essentially you're looking at the sun in the past. But what I find even more fascinating is that light has come from the centre of the sun, and it takes over 100,000 years. I think it's like 160, 170,000 years to reach the surface. Before then, it takes 8.5 minutes to reach us. So it really does take a long time for those little photons to actually reach the surface of the sun.
So why does it take, would you say, 100,000 years from the center of the sun to reach the surface? Is it the gravitational pull of the sun?
It's to do with the fact there's a lot of scattering processes and off the particles in the sun. So it actually takes the photons quite a long time, because it's not a straight path out of the sun. There's actually a lot of collisions and a lot of interactions that go on. And so that's why it takes so long to reach the surface. And then once it's out into space, it just travels out.
Very interesting. Thanks for that tidbit. It's always interesting to ask that question. I ask it infrequently, but maybe I should start asking it more, because it's kind of enlightening. So thanks for that, Stephanie. Stephanie, what is one thing that really has you fired up today?
If you're talking about my subject and what I'm doing at the moment, I think we're really getting to a point, we're really starting to reach these milestones, I think, in not just solar physics. I think in space travel in general, we have all these private companies like SpaceX, Boeing and Virgin Galactic, and we're all starting to hit these milestones where we're starting to see space travel as a more common thing. We're putting the money into it and we're actually going there. And so I think recently SpaceX had one of their rockets reach the International Space Station and docked with the International Space Station and actually return back to Earth. So it's things like this, and we have some satellites at the moment. So you may have heard about the Parker Solar Probe satellite, which is actually the closest object to the sun at the moment. So it's inside the orbit of Mercury, and it's actually the fastest travelling object in our satellite in our solar system at the moment, or in space in general. So I think the fact that we've got this technology, the technology is finally catching up, and we're able to do these things that were maybe once science fiction are now starting to become a reality. I think that's something that's very exciting.
All right. And thanks for that, Stephanie. And we're going to move to an aha moment. Could you take us to a time of incredible aha moment you had and how you may have turned that into success?
I think I've already given it away, unfortunately. I think it was that moment where I went on that amazing trip I met all these amazing people that either worked at NASA, and we got to do loads of activities. So I got to be in the old control room at Houston, Texas, at the Johnson Space Center, and I got to say the famous words, "Houston, we have a problem." So I was actually I was the commander at one of the stations, and there were two teams going on. There was the one team that was doing all the experiments in a separate room, and that was kind of simulating being up at the International Space Station or something. And then there was the communications team down back on Earth. And we were essentially, what they were doing is we were simulating these experiments, and all these problems were being thrown in to, it was going as far to see how much we could cope with. And so everything was going swimmingly, and then there'd be certain problems and you'd have to communicate things to the team backwards and forwards, a bit like a real mission, a bit like what you'd imagine some of the Apollo missions are like. And it was very interesting and actually quite stressful at the end. But the fact that I got to sit there and joke and utter those words, "Houston, we have a problem," it was moments like that that really thought this really made me think, this is what I want to do. I want to be involved in something like this, or work in this kind of industry. And that was my kind of moment where I thought, yeah, this is what I want to do.
At STEM Nation, you have to take advantage of experiences as they come along. And if there is no experiences coming along, go seek them out to get the experiences. See what is it that really would have you jazzed up about what you could do in the future. So, all right, Stephanie, and you've got a PhD, which means you had at least, I don't know if it's the same in the UK as in the US, but you have a bachelor's degree and a master's degree, and then you went on for your PhD. Is that correct in the UK?
Yeah, so it's very similar here. I think the timing's slightly different. The only difference that I had is my bachelor and my master's were actually together, and that doesn't even happen that often in the UK. I did 4 years to study for my master's, and when I got my master's, I got my bachelor at the same time, and then I spent 3 years studying for my PhD, which is, I think, is quite condensed compared to the US system. I know some people spend about 5 or 6 years doing their PhD.
Yeah, that does sound condensed. It sounds like the PhD is typically longer than that, which means that you had to work really hard, I'm guessing, to get through all the way through your PhD. What is some advice that you'd give to STEM Nation thinking of pursuing all the way through a PhD so that they could be successful through college?
So I think you touched on it a bit, really. I think one of the main things, or one of the best pieces of advice I've been given, and one that I've taken, to take every opportunity that is, that you have, that is given to you. And that really, really helps, I think, for you to progress. Another thing is just perseverance. To do a PhD or to get that far, you obviously have to be good at something. You have to have some talent. But I think a lot of people don't realise a lot of it's more about perseverance and actually picking yourself back up if things go wrong, and carrying on, essentially. So I think it's mainly having the perseverance, and also just being quite organised and having everything, keeping on top of everything. I think perseverance is a massive quality to have.
Yeah, I agree, Stephanie. I mean, you got to have some talent, right? You got to have some abilities, but it's really the grit, it's the perseverance, it's sticking to it and just grinding through it. And you're going to have the failures along the way, absolutely. But it's how do you react after those failures? Do you pick yourself up, or do you just get down on those? And I think that those are the differentiating aspects of the qualities to be successful through college.
Yeah, and I think if you find something you're really passionate about, then it makes it a lot easier to do it. Because sometimes it can be very hard when you have rejections, or something doesn't go quite the way you've planned, but you can pick yourself up and turn it into an experience and go, well, that's happened, it's out of my control, I'm just going to carry on. And you've got the perseverance and the passion about that particular subject or something you're particularly doing, then you'll look back at it in future and think, well, that happened, but I'm where I am today. It doesn't, just because you failed doesn't mean you're a failure. It just means that you just need to keep going until eventually it will work out in your favor, essentially.
Yeah, absolutely. And Stephanie, we're going to take a quick pause to thank our sponsor, Audible. Audible is offering a free audiobook. You could head to stemonfirebook.com. That's stemonfirebook.com to get a free audiobook of your choosing. If you decide to cancel within 30 days, there's no cost, and you keep the audiobook. And Stephanie, it's lightning round time. Are you ready?
I think so.
All righty. What is the best piece of advice you've ever received?
So I touched on this. I think it's to take every opportunity that you get given.
And a personal habit that contributes to your success.
I think I'm quite a conscientious person, but I mainly think it's the perseverance.
And a favorite internet resource or phone app, and why?
So I quite like, there's two that I like. There's the Night Sky app because I like stargazing and I like running stargazing sessions, and I think that's free as well. Or one that's more personal to me is the Solar Dynamics Observatory app. So one of the satellites that studies the sun, you can actually download images of the sun, the latest images of the sun to your phone.
Awesome.
For free.
Yeah, I'm going to go check that one out because we sit around the campfire and we look at the stars and we have the stargazing apps, and we'll go get the sun app. Awesome. Thanks for that, Stephanie. And if you had to recommend one book, what would it be?
So it's one that's quite close to my heart, is 15 Million Degrees, and this is by Professor Lucy Green, who was my PhD supervisor. So that's one that I got on my bookshelf.
Well, that'll all be in the show notes. And Stephanie, if somebody wanted to connect with you to get more insights or to understand a little bit more about what you're doing, how would be the best way to get a hold of you?
So there's various ways, but the main ways are probably through Twitter. So I think my Twitter handle is SL Yardley, so YARLEY.
Right. And Stephanie, we'll put that in the show notes along with your LinkedIn connection. And as we wrap up here, could you share a parting piece of guidance for STEM Nation, and then we'll say goodbye?
Just not to give up and to go for it, to really go for, if you've got something you're passionate about, then don't give up and go for your dream or your goals that you set.
All right. And with that, Stephanie, we will say goodbye.
Thank you very much for having me.
You're welcome. I hope you enjoyed our chat today with Stephanie. Head over to STEMonfire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on your favorite podcast player and share with a friend. Tune in next week where we talk with Rebecca, who is focused on epidemiology and biostatistics. Until next time, I hope this chat has helped ignite your passion in STEM.